Review problem number 6. In this problem we're exploring terminal speed. So let's talk a little bit about the phenomenon of terminal speed. This is what happens when an object is falling under the influence of a gravity force, but there's also an air resistance force. Or possibly this could happen in some other medium, maybe it could happen in water and there would be a water resistance force, something like that. The idea of terminal speed is that the resistance force depends on how fast you're going. The faster your speed, the more resistance you feel. Now this should probably be familiar from daily life. Maybe if you've ever stuck your hand out the window of a car while you're driving, you notice that if you're driving slowly, you just feel a slight breeze on your hand. But if you're driving fast, you feel quite a big push on your hand. Maybe if you've ever had the experience of skydiving, you've experienced a very big force of air resistance. Now, the simplest way to model this mathematically is to say that the air resistance force, I'm going to use the symbol R. I think in the problem they use F, but I like to use R for resistive force. You say that it's proportional to the speed you're moving, and there's some proportionality factor B. Now, this B depends on the shape of the object. It depends on how aerodynamic it is. If you have an object that's very aerodynamic, like a pen pointing straight down, that slices through the air pretty well, and there's not a whole lot of air resistance on it. If you have an object that's very flat, like a disc shaped, and it falls, it has a large B value. It will have a big resistive force on it. Sometimes you want a very small B value. That would be usually the case when you're designing a vehicle. Like if you see a high-speed train, bullet trains like they have in Europe and Japan. The front of the train, the nose of the train is very sharp. That's so that it's aerodynamic and it has a small B value to try to minimize that resistive force so the train can go very fast. On the other hand, if you are building a parachute, you want to make as big a B value as possible so that the parachute slows you down when you open it. You're trying to increase that resistive force by using a parachute. Okay, so let's say that we drop some object and it's falling under the influence of gravity. It experiences a resistive force. How can we calculate what its terminal speed is? What's that maximum speed that it can attain? And what does that really mean? So let me draw a free body diagram for the situation. Let's say we've got an object. I'll just draw it as a ball shape. It's fallen, so gravity is pulling down, and it's got this resistive force. All resistive forces, air resistance, friction, whatever, they oppose the direction of motion. So if you're falling downward, the air resistance force points up. If it's a bullet train and the train is going this way, then the air resistance force opposes the motion of the train. Okay, and we can write down Newton's second law for the y direction. We've got R in the upward direction, we've got the weight in the downward direction. And now here's the key thing. Terminal speed. VT for terminal. This occurs when the air resistance force has the same magnitude as the gravity force, which means that the acceleration is 0. It doesn't mean the object stops in the air. It just means it's moving with constant speed now, and that's the fastest speed it can attain. So we have this relationship, r minus w equals 0 at terminal speed. So the resistive force equals the weight, and now we can substitute in these expressions. Resistive force is B times V, and we're going to use the terminal or fastest speed value there. There's mg, and so the terminal speed equals mg over b. Now you can look at this equation and understand some things about terminal speed. The bigger the object's mass, the bigger the gravity force will be, and the larger its terminal speed. The bigger the b value, the more air resistance the object experiences, and the smaller the terminal speed will be. So the terminal speed has some competing factors. It gets increased by an increase in mass. It gets decreased by an increase in this b value. So the less aerodynamic an object is, the smaller its terminal speed will be. So in a problem relating to terminal speed, I might ask you to calculate the terminal speed value for some scenario. That's pretty easy to do. This is a simple equation. But I also might ask you to explain this phenomenon of terminal speed. What does it mean for an object to be at terminal speed? And so you can describe some of the things I've been talking about in this video.